Hello everyone, and welcome to Kanai's AI Lab. AI is no longer experimental. It's becoming a core part of how modern businesses operate. AI models are quietly transforming entire industries. In this video, we're going to break down how these models actually work, what large language models really do, and how they are applied in real-world business scenarios. Let's start with the foundation. Artificial intelligence is the broader concept of machines performing tasks that typically require human intelligence. Within that, machine learning allows systems to learn patterns from data instead of being explicitly programmed. And deep learning takes this further by using neural networks to process complex inputs like text, images, and speech. From a business perspective, this layered approach is what powers real applications. Machine learning is used in fraud detection systems in banking. Deep learning drives recommendation engines in e-commerce platforms. And AI integrates everything into intelligent decision-making systems. Now let's understand how an AI model is actually built. In real-world projects, there is a structured pipeline. It starts with data preparation, cleaning and organizing raw data so that it becomes usable. This data is then split into training, validation, and testing sets. During training, the model learns patterns from the data. Validation ensures that the model doesn't simply memorize, but can generalize. Finally, testing evaluates how well the model performs on completely unseen data. Think of it like a business scenario. If a retail company is building a demand forecasting system, it trains the model on past sales data, validates it against recent trends, and tests it before deploying it into live operations. If this process is not handled correctly, the impact is immediate. Incorrect forecasts can lead to stock shortages or overstocking. In practice, companies rarely build models from scratch. Instead, they rely on pre-trained models and adapt them to their needs. This approach is known as transfer learning. For example, when building a customer support chatbot, a company does not train a language model from zero. It takes an existing model and fine-tunes it using its own customer interaction data. This significantly reduces development time, lowers costs, and improves performance. This brings us to large language models. LLMs are trained on massive amounts of text data and are designed to understand and generate human-like language. They are widely used for generating content, writing code, summarizing information, and interacting with users. In a business setting, an LLM can analyze hundreds of customer feedback entries and generate meaningful insights within minutes. This allows teams to make faster and more informed decisions. However, it's important to understand their limitations. LLMs can sometimes produce generic responses if they lack domain-specific context. They can also hallucinate, meaning they generate information that sounds correct but is actually false. They require proper customization to be useful in specialized industries, and their knowledge is limited to the data they were trained on, unless additional systems are integrated. In critical domains like finance or healthcare, these limitations can have serious consequences. That's why organizations use techniques such as retrieval-augmented generation and fine-tuning to make these models more reliable and context-aware. Looking ahead, the next generation of AI is moving beyond simple responses. We are seeing the rise of agentic AI systems that can plan and execute tasks autonomously. Multimodal models are emerging that can understand and generate not just text, but also images, audio, and video. Smaller, specialized models are being developed for specific industries, offering better efficiency and privacy. And personalization is becoming a key focus, where AI systems adapt to individual users and business workflows over time. Imagine a system that can read incoming emails, identify key actions, create tasks, and update dashboards automatically. This is not a distant vision, it is already becoming a reality. To summarize, AI is shifting from being an experimental technology to becoming a core layer of modern systems. Understanding these fundamentals is essential for anyone looking to work with or build AI-driven solutions. Thank you for watching this video. Stay tuned for the next section, where we will dive into customizing large language models for real-world applications. See you in the next deep dive with Kanai's AI Lab.